Homework Hotline, what is your emergency?
Hi everyone, the Homework Hotline is back after our Thanksgiving break. We've had plenty of turkey and relaxation, so we are ready to get back to work.
We're here live to help you on Tuesdays and Wednesdays from 4:30 to 5:30 p.m.
So how can you watch us? Tune into Comcast Channel 22, Prism TV Channel 8007, or go on the internet to YouTube us at Denver DPS TV, Facebook at EG Homework, or live stream at livestream.com. Search for DPS TV 22.
And the best way to get your question answered is to give us a call. When you call, we'll interact with you and walk you through your problem. You can call us at the number on the top over here, making sure I was pointing the right way, at 720-424-1666.
So we're here to answer your science and math questions. I'm Sam, and I can help you with your science homework questions. Nathan and Becca over here can help you with math. We're all high school teachers. I teach at the Contemporary Learning Academy, and Nate and Becca teach at Emily Griffith High School.
And since today is Tuesday, we're also going to have a special guest. Adam Kohlberg is here from the Pop Culture Classroom. I admit I don't know much about it, so I'm pretty excited to interview Adam later in the show and learn a bit more.
As you know, we love your phone calls, but we also know that doesn't always work for you. So we do have someone monitoring our social media. Jordy, why don't you tell us a little bit about yourself?
Hi guys, I'm Jordy. I'm a student at MSU Denver, and I'm an intern here at DPS TV. And as Becca said, I'll be running the social media board, so you guys can send in some questions on email, Twitter, Facebook, and I'll make sure these questions get over to them. And my other job is actually the trivia master. So at the beginning of the show, we'll give you a trivia question, and you can call in throughout the show if you think you have an answer to it. And right as the show is going to end, we'll give you the answer to that. So if you think you know the answer, go ahead and call in. So today's trivia question is a geology question. What is the deepest river gorge in North America? So if you think you have an answer to that, go ahead and call in.
As Jordy mentioned, that you can call your answer to the trivia question in, but you can also get a hold of us a few different ways. So Jordy can get the questions from social media. So let's give you the rest of the ways that you can get a hold of us. So the phone number was mentioned before by Nathan, but we also have a couple other ways to get in contact with us. You can get us on Facebook at EG Homework, or also Twitter. You could text your questions or your trivia answer to us at 970-680-3771, or you could email us at homework@emilygriffith.edu. So you've got a lot of options, a lot of different ways that you can get a hold of us until 5:30 today. So let's go back to Jordy and start answering some of the questions that have been left for us on social media.
All right, the first question I have for you guys today is a math question. So Kim's current monthly rent is $800. She is moving to another apartment complex where the monthly rent will be $1,100. What is the percent increase in her monthly rent amount?
Oh.
Right. I will take that one.
Okay.
I'm just writing it down right now. So Kim's rent was $800, and now it's increasing to $1,100, and we want to know the percentage increase. So we can figure out the dollar increase pretty easily, that her rent is now $1,100. She used to pay $800, so her rent increased by $300, but we want to know the percentage increase. So there's kind of a formulaic way of doing this, or you could just think $300 out of her original rent, how much is that as a percentage? So what we could do is we could say, what is Kim's current rent, or her new rent, minus her previous rent, and that'll give us that $300 that we talked about up here, because we really want to know what that increase was. But we want to figure that out as a percentage of her old rent. We just end up dividing that by her her previous rent, right? Because we want to know the percentage increase out of her previous rent. So this is one way, and this really works for any kind of percentage increase. If you wanted to know how much your, I don't know, hourly wage increased, your hourly, yeah, I guess wage is the right word. I don't know why I was trying to think of a different one. So you could just say, what is your new wage minus your old wage divided by your new or your old wage. So all we're really doing here is we're saying equals the new rent, like we did up here, 1,100 minus 800 divided by 800, and you end up with that 300 we talked about, divided by 800. And then we just do this in our calculator. So 300 divided by 800, is going to be 0.375. Now, we want a percentage increase. Like, this is a decimal, so this isn't exactly what we're looking for, but this is 0.375 out of 1, so you could multiply this by 100, and that will give you the actual percentage increase of 37.5%. And again, this will work with any kind of increase. I don't know, when I teach this sometimes, I think students sometimes get confused on, or they mix up whether they should do new rent minus a previous rent, or they should do previous minus a new, and sometimes get it backwards. The way I always think about that is, does this answer make sense? Her rent went up, so you would want to think about, like, that needs to be a positive number. If you did this the other way and you did 800 minus 1,100, and again, I encourage students, like, if they're not sure, to just try it the way that they think, and you would see that you get a negative 0.375. So if your rent went up, it should be positive, so you should automatically look at this and think, oh, it went down, so that wasn't wrong. I should do it the other way. And I kind of think that's a good way of, like, if you don't remember something, just try something, see if it makes sense. A lot of times you can figure it out from there. But that is a pretty lofty increase of 37.5%. So it sounds like Kim probably lives in Denver, because that's about how much rent goes up every year, I think.
She lives in Denver.
37.5%. So that seems reasonable in our current rental market here.
Yes, it does. Not surprised that our rent is that expensive as well. All right, let's go back to Jordy and get some more questions answered.
All right, so this next one is going to be about sedimentary rock formation. So this will be for Sam. Which of the following best describes how a sedimentary rock can form? And we have 4 options: compaction and cementation, slow cooling and hardening of magma, fast cooling and hardening of magma, or high temperature and pressure causing crystallization.
Okay, great. An old WXYZ question. Sedimentary rocks, well, I think the way that we'll try to answer this is just by talking about what a sedimentary rock is, what other kinds of rocks there are, and then just sort of we'll work backwards and try to figure out which answer makes the most sense. Sedimentary rock, the sort of hint to what type of a rock it is right there in the name, sediment. So sediment is a word that essentially means fine grains of rock. You can think of, like, sand as being sediment, or even just dirt or clay particles as being sediment. But a sedimentary rock is ultimately some kind of a rock that is made up of these sediments, and over time, that layer of sediments, let's imagine a beach, right? So a beach is just a lot of sand along the ocean, and we'll imagine that over a long period of time, tens of thousands, hundreds of thousands, millions of years maybe, this beach gets covered in other sediment and gets buried deep in the earth, and the whole landscape changes, but that beach, the sand that was part of that beach, is still there, buried underground. At a certain depth, under a certain level of heat and pressure, 2 things take place: compaction and cementation, and this sand sort of glues itself together and becomes sandstone. And if we could jump to my screen really quickly here, I've got just sort of a really basic diagram that's often shown in like a physical science class in middle school. This is called the rock cycle. And you can see here we have some sediments, and then through, again, those processes I mentioned, compaction and cementation, you end up with sedimentary rock. The key with the rock cycle is that any kind of rock can become any other kind of rock just based on sort of the process that it goes through. So if a rock is broken down to sediment, any kind of rock broken down to sediment and then compacted and cemented, it's now a sedimentary rock. If you take a sedimentary rock or any kind of rock and you heat it up enough that it starts to bend a little bit because it's melted, but it hasn't melted down to being liquid, you're going to end up with a metamorphic rock. So heat and pressure sort of get it to this place where, almost like if you can imagine a candy bar in your pocket that gets hot from the heat of your body, and so it kind of warps, but it still holds a little bit of its shape. That's a metamorphic rock, or that's sort of an analog for metamorphic rock. And if any kind of a rock gets melted, it gets buried so deep in the earth that it gets melted all the way to magma or lava. When that magma cools and becomes rock again, it becomes an igneous rock. And then I'll just really briefly show here. Here's a really beautiful picture of the Grand Canyon. A deep gorge, by the way, although I don't know if it's the deepest. But it is a deep one.
Good guess.
But just going to throw that out there. But really beautiful scenery. People love this for lots of reasons. But one of the great things you can see in the Grand Canyon is layers, and I'll just sort of use my cursor here, layers of rock. And these are layers of sedimentary rock. As you get down to what are called the basement rocks in the Grand Canyon, you actually get to some metamorphic rocks. I'll show just another side view of the Grand Canyon here. Up at the top, you have the Kaibab limestone. The Toroweap Formation is going to be shale, and you have sandstone below that, more shale. All of these are types of sedimentary rock. Sediments, grains that were compacted together. But as you get deep down below the Bright Angel Shale and the Tepiatz Limestone, there's the Vishnu Schist right at the bottom, and schist is actually a kind of metamorphic rock. So anyways, there's just a little bit of background on all those rock types. Looking back at the question, if we can jump back to Jordy's screen, which of these is going to describe how a sedimentary rock can form? Well, as I've mentioned, compaction and sedimentation are those kinds. The cooling of magma, slow or fast, will give us an igneous rock, whereas recrystallization is likely going to be a metamorphic rock. So hopefully that's a little more information than maybe you needed, but hopefully that helps.
All right. Back to Jordy.
All right. So this next one is a probability problem.
Ooh.
A spinner is divided into 8 equal parts. Half is blue, 3/8 is pink, and 1/8 is yellow. If you spin it 10 times, what is the best prediction possible for the number of times it will land on blue or pink?
I will take this one. I used to teach middle school, and this was a big section of the 6th grade stuff.
It's a pretty common type of problem too, right?
It is, but there's a lot of spinners involved in
Yeah,
6th grade math. But
Yeah.
it's fun. It's like a lot of games, so
Yeah.
you know. All right, so if you go to my screen, I just drew a spinner real quick of what they're talking about in this question. And it says a spinner's divided into 8 equal parts. So I took my spinner, I divided it into 8 parts. Half of it's blue, so let's color half of this blue. Is there a fill tool on here? Do you know?
Not that I know of. I think I was looking for one before and couldn't find
You
it.
just got to use the highlighters.
Yeah.
Okay, so half of it's blue, so that means 4 of my pieces are going to be.
You're very good at coloring, though.
Oh,
That's
thanks. All right. Half of it's blue. Okay. And then we've. Oh, no. Come back. Come back.
Yeah, wrong way.
Ah. Half of it's blue. It's not going to be as pretty this time. Man. All right. So half it's blue. 3/8 is pink. So that means we're going to make 3 of our 8 pieces pink. Pink, not as pretty this time. Not as motivated to make it pretty because it's just going to disappear on me.
Yeah, that's tough.
Yeah, because you can't act like you're crossing something out. Otherwise, it just thinks that you're crossing it out.
Right.
Sure, there's a way to fix it. Okay, and then 1/8 is yellow. So I'm drawing. All right, so there's my spinner. This doesn't look like a very fair game, if you ask me. And then they want to know if you spin it 10 times, what is the best prediction possible for the number of times it will land on blue or pink? So we're actually finding what's called experimental probability, meaning it's what would likely happen. It's not really tried and true. But if you were to spin the spinner, enough times, that eventually what would happen is the experimental probability would actually match the theoretical probability, which is the literal probability of it. So we're wanting to know the probability that it is going to land on blue or pink. So if you think about this spinner, if we landed on blue, it would be 4 out of 8 times, possibly. So 4 out of 8. Plus, if it landed on pink, that would be 3 out of 8 times. So it's going to land on blue, or I said 8, not 7. It's going to land on blue or pink 7 out of 8 times. So we could say the probability of blue or pink is 7/8. So 7 out of 8 times. Now, the thing that is a little tricky is that they actually asked us to find out, well, theoretically, if it was spun 10 times, how many times would it land on blue or pink? Here we're talking about 8 times. So there are a couple ways that you could do this. I might just set this up as a proportion, just because, I don't know. So 7 times it's landing on it, and then 8 is the total times you're spinning it. So if you set up a proportion, we'd say maybe 10 times total we're going to spin our spinner, and that we don't know how many times it's going to land on it, and that's what we want to know. So we can set up a proportion. We can cross multiply to solve this one. So we would start by doing 7 times 10. So multiplying across that equal sign there. And then is going to equal 8 times x. And then simplifying that left side, we have 7 times 10, which is 70. It's equal to 8x. We could divide both sides by 8. And I'm going to use my calculator because it's going to be a decimal. And we end up getting 8.75 times. Now, I don't know. I would round up to 9 times, just because it asks the best prediction possible, and 8.75 is closer to 9. So I would round that up to 9 times, thinking about, I don't know, you can't really spin a spinner 8.75 times.
Right.
Doesn't really make sense. So I'd say 9 times out of 10, it would likely land on blue or pink. Now, that second part that I did, there are a bunch of other ways that you could solve that, but that's kind of the nature of proportions and ratios, is there are a lot of different ways to do it. Would you suggest a different way, Nathan, or?
No, actually, I like that you set it up as a proportion. I would have just taken the 7/8 and multiplied by 10, but I think the proportion really kind of like, I don't know, it really shows like what's actually happening. The multiplying by 10 is kind of just a shortcut.
Right.
But I did like that you kind of rounded up the 8.75, and I think it's important that noting that experimental probability doesn't mean it will definitely.
Exact. Yeah.
Theoretically, it's possible that it never lands on blue or pink out of 10.
It could happen.
But I think the 8.75, if you didn't round up, you could also apply that to like, what if you spun it 100 times, and then, or actually 1,000 times, you get 875, a more realistic number.
And the more times, and that's important to note, the more times you perform an action, the more accurate your data is. So if I were saying how many times out of 2 is it going to land on that, we couldn't really predict that very well. Whereas if we do 10 times, we can predict that a little bit better, 100 times even more, 1,000 even more, and so on.
And if you did it like 1 billion times, it would get very, very close to that 8.75 out of 10, like almost exactly if you worked it out.
Yep. Love it. All right, let's go back to Jordy and get some more questions answered.
All right, so this one is for Sam. What is the primary oxygen-carrying protein found in red blood cells?
Yeah, so the answer to the question is hemoglobin, but I'm going to talk about it for a little bit. So you may be aware that your red blood cells are sort of the oxygen-carrying transport units of your body. As you take oxygen in through your mouth, as you breathe into your lungs act as sort of a filter system that allows oxygen to come into contact with your blood. Your blood cells pick up that oxygen and then travel throughout the body, providing oxygen to cells that need it. And by the way, cells need oxygen to metabolize food, specifically sugar. But if you didn't have oxygen, I was having a conversation with my students recently where we were talking about why is it that not being able to breathe would kill you. And we had a hard time getting past, well, you need oxygen to live. Well, yeah, you definitely do need oxygen to live, but the question is why? And the reason is you can't get energy for your cells without oxygen. Your cells require oxygen to break down that energy and get it into usable form from some kind of food like sugar. And so cutting off your oxygen supply essentially starts to kill your cells as they're not able to receive oxygen. Blood cells are kind of special. If we could take a look at my screen really quickly, this is a basic diagram of a general cell that might be found in your body. Has a cell membrane and then all these little parts inside called organelles. Blood cells, often called red blood cells, are sort of special because once they form, they jettison some of the extra stuff that they won't need anymore. Like, for example, they jettison their nucleus with all their DNA. So once the red blood cell is set up, it's set up to live its life out, which I'm blanking on how long they actually exist, but it's not too long before they essentially get broken down and you have to create new red blood cells. But the big important thing that the red blood cells do contain is this special kind of protein called hemoglobin. Hemo meaning blood, globin being the type of protein. A tiny hint for a biology class: if you're ever looking at chemicals found inside of a living organism, and those chemicals end in the suffix -in, like globin, that -in there, that indicates that we're talking about a protein. So I'll just briefly show you guys. Here's sort of a simplified version of what hemoglobin might look like. It's a complex strand of amino acids, but contained in that complex strand is little bits of iron. And the iron in there is actually able to attach to oxygen. And this might seem a little strange, like why do we need iron to hold on to oxygen? Well, iron is especially good at attaching to oxygen, and you might know this because you've probably seen this stuff before, which is rust. So when we make things out of iron and then we leave them exposed to oxygen, oxygen will latch onto the iron molecules and cause it to, we call it rust. You also in science might call it oxidizing. And it turns the iron from its sort of, normal metallic black sheen to this reddish color. And actually that's the reason why your blood cells are red. And a bright red when they're oxygenated is because they are pieces of iron holding onto oxygen. And when an iron molecule is holding an oxygen molecule, it reflects red light, whether that's rust or in blood cells. So anyways, really long-winded answer to the question. The answer was hemoglobin.
Okay, well, we're going to take a little bit of a break, and when we come back, we're going to be speaking with Adam Kohlberg from the Pop Culture Classroom. So we'll see you in a minute.
When you look into a barbering class at Emily Griffith, you see students youthful and mature.
The instructors that we have here are just phenomenal.
Very proud to be going to this school.
Jesse and Robert Gallegos share a classroom.
I had to wake up some dead brain cells that I didn't even know I had anymore.
What else do they have in common?
I'm retired from UPS.
Retired from the railroad for Union Pacific.
They've both quit one career and are starting another.
It's something that I always wanted to do. My son and I are planning on opening up a shop.
I own 2 barber shops. I bought them both as investments. Now that I'm retired, I want to be able to go into the shops and do more than just dump trash and sweep floors.
These two are also brothers that are returning to a schoolroom after nearly 40 years.
Now I'm going back home having to do some homework, and that's just so hard to discipline yourself.
It's a challenge. It's fun. I'm only 57 years old now. I have a lot of energy.
They're surprised at the rigor of the barbering program.
It's a lot more difficult than I imagined.
I never done well in science. I never realized there was so much chemistry and biology in this class.
I thought, how difficult can cutting hair be? But coming in here and seeing all the book work, there's a lot of study involved.
If one career isn't enough for you, these two should certainly inspire.
When you get into something that really something you want to do, you just devote more time to it.
Push yourself. This is a great school.
If it's in their heart and it's really something they want, you're never too old to learn.
Hi, welcome back. We are here with Adam Kahlberg from the Pop Culture Classroom. Welcome.
Thank you. Great to be here.
Yeah, thanks for coming on our show.
Of course.
So first, I think that you should tell us and our audience, what is the Pop Culture Classroom?
Sure. So we're a Colorado-based nonprofit, and we run programs all across the city. And our mission really is to ignite a love of learning and build community and increase literacy and engagement in the classroom through the tools of pop culture. So those things include things like games, comics, graphic novels, cosplay. So using those in sort of an educational setting. And so we actually kind of started in 2009, 2010, teaching sort of small-scale workshops, and we've grown really significantly in the last 5 years, and it's been great so far.
So is this kind of is this kind of like a full curriculum?
It's actually, we are a nonprofit, so we develop curriculum, resources for teachers. We go into schools and teach things.
Oh, okay.
Yeah, so we kind of do the full gamut of things, yeah.
Gotcha.
And our big event every year that a lot of people know us for is Denver Comic Con, which is, a lot of people know is nonprofit run, and all the proceeds we make from Denver Comic Con goes back directly into our nonprofit mission. Yeah.
Very cool.
Yeah.
Okay. What subjects do you do? I have to ask because I always am wondering, like, okay, how can I make this work in my room? How can I make that work?
Yeah.
What subjects do you do?
So we teach kind of the full range of anything you can think of under the pop culture umbrella. So we have a comics course that we teach in after-school programs, as well as in, different community centers and libraries across the state. We also have a game design course, and we go and teach how to build board games from the ground up.
I can see some math, and we just did a spinner problem.
Yeah, yeah, exactly.
Could see
some kind of spinner game.
It's got some great STEM approaches in there too, so it's really fun. And then we also have a new curriculum coming out that we're working on right now, which is a cosplay curriculum. So teaching character development, kind of engagement with role playing and those sort of things through building a costume and dressing up and performing.
Oh,
yeah.
I can see it being really easy to connect to theater classes and performing arts. And
history, social studies too, kind of from that angle. Yeah.
Very interesting. Well, what's your role at the Pop Culture Classroom?
I am the education program manager. So what I do is I'm in charge of organizing all of the outreach that we do. So we have a crew of about 11 teachers, and we send them out to sites throughout the city and the state. And we also build curriculum, and I do that with our education director. And I'm also responsible for running things like community events and all of the educational components of Denver Comic Con too. So a lot of people don't know about that we have about 400 or so hours of panels at Denver Comic Con, and last year we had 250 plus that were education focused. We also have some educator focused activities and events there that go on throughout the weekend. Yeah.
Wow.
I mean, do you support teachers at all in doing like gamifying the classroom? I sort of hear some of that stuff.
Yeah, I mean, gamifying the classroom is one way to approach game design. We think of it more as putting the tools in the students' hands and allowing them to build a game based on whatever topic or theme that a teacher might want to assign them. So we've seen things like building games around using genetic materials to, whether that's right or wrong, for I don't know what the word is, for making babies, designer babies is the term that people get talked about a lot.
Okay.
We've also seen things like, ones on social studies, English, using math in a lot of those games and things like that. So kind of anything under the sun that a teacher wants to assign, a student could build a game around it.
Okay.
Yeah.
Okay.
So the gamification is more of like a grading system. So where they are actually assigning like medals for grades, or maybe
Gotcha.
saying that students level up when they reach a
Sure.
certain goal or reach a certain, turning in an assignment on time or attending for a week straight. They might level up, but ours is more the idea that they can build their own game
Right, to
that
teach the
works
content.
any way they want. So the teacher doesn't design the game that
Gotcha.
the students play. The students design the game that the teacher plays.
That's really cool.
Yeah.
We had a science teacher last year that was doing that kind of stuff, was trying to get the kids to develop games to teach science.
Yeah.
So there was that type of a thing that went on where there was essentially like a large class board game that different students got to be like miners or renewable energy folks or factory workers, and it was all on energy and renewable resources, and it was essentially this big economy that got created, and you got different bonuses depending on what you were, but then also had to pay certain taxes.
Yeah.
And it worked out really well. I thought that the students really got into it, so I'm excited to hear that there's this resource.
Yeah, and there's kind of it's structured so that there's two versions of it. You're describing kind of what we call resource management, which is where you're using resources and building a civilization or something along those lines, and you're kind of trying to match those resources with the different materials that might have existed at that time or in that subject. So there's another one that we do which is called roll and move, which is just kind of rolling and moving across. So that's more like Candyland, whereas like a resource manager would be like Settlers of Catan or Risk,
Right.
or even something like chess. Yeah.
Very cool.
I remember making an Oregon Trail game back in the day. It was like a board game. I mean, it was kind of like Oregon Trail, the computer game, right? You landed on a space and like you died of dysentery or something.
Yeah.
But yeah, I remember making one of those. That would kind of fit in. So wait, you have curriculum materials that you offer teachers. What did you bring here?
So I brought a couple different to show y'all. This one's called Storytelling Through Comics. Put it up here. And so what this does is it teaches literacy and art skills through the medium of comic books.
That's cool.
So students build their own comics from the ground up. So they learn the vocabulary of comics, what comics offer in terms of the value, whether it's from sort of an educational standpoint or a cultural standpoint. And then they're able to, once they learn all those different aspects and learn the art skills and the vocabulary and the storytelling skills, they're able to sort of build their own comic. And again, it's made so that any teacher can use it in any subject. So we've seen every subject use this in their classroom, so it's great.
Oh, that's cool.
And then, yeah, of course. And then this is our newest curriculum. It's called Game On. And what this is a game design curriculum, which we were just kind of talking about. And it's for levels 2nd through 12th grade. The Storytelling Through Comics is levels 4th through 9th grade. Yeah.
I like this. There are rubrics in here. This is not just coloring or anything. There are rubrics in here.
Yeah. So
there are all different instructional things. Yeah, it's not just drawing and coloring. It looks like it's Common Core aligned as well. That's so cool.
Yeah, so all of our curricula are Common Core aligned. They have some 21st century standards connections as well, and they have all the assessment tools. So our focus as a nonprofit when we build these type of things is to remove barriers, barriers to these sort of subjects and topics that maybe are a little bit out of reach for some classrooms, as well as barriers teachers face in terms of getting the right assessment tools or the right resources that they might need. So the Storytelling Through Comics, for example, comes with about 90 minutes of art instruction videos that teachers can play for the students or watch themselves and learn a little bit about how comics get created.
So no worries if you can't draw yourself, you can still teach it.
Yeah, and the same thing with game design. Our goal is to really teach the students what those building blocks are of a game or a comic, and then allow them to take that knowledge and put it into action.
Oh, this is cool.
How can a teacher or a student get access to these resources?
Yeah, so I think our website has been kind of scrolling across the bottom of the screen as we've been talking, but they can visit popcultureclassroom.org, and if you just search Google for Pop Culture Classroom, we're going to pop up. And you can also search for Denver Comic Con, which will lead you back to Pop Culture Classroom as well. And so the curriculum that I was just telling you all about was it's $50 for the whole curricula. So you can get each one for $50, and that's a one-time cost. And then we also have some free resources on there. So if you want to know what comics might be good for different ages to read, different subjects, as well as some ideas for maybe different games that you could play that are age appropriate for all the way from 2nd through 12th grade.
Oh, that's what I was about to ask you, actually. So you go the whole kind of education or kind of age range, right?
Yeah.
Oh, that's interesting.
Yeah, because we want to make this available to any student who's looking for it, as well as any teacher who's looking for it. Yeah.
Very cool.
Yeah. And that also helps us when we come to Denver Comic Con, and a lot of what this comes from is seeing the inspiration and the excitement that people feel when they come to the event, and trying to find a way to get that out to maybe some of the students who can't afford to go, who aren't able to go, who maybe are not sure that if it's for them, if this pop culture aspect is for them. So we want to go out in the community and share the value that we feel pop culture adds, not only to a classroom, but to any community, to a small school or a large school or an entire district, which we feel like, it brings people together regardless of their, age, race, income, background, and those sort of things.
Yeah, I definitely know a few students who I feel like if I could integrate that, they would be way more invested, just because they're so interested in it, and they see maybe a disconnect between that and school, and it's not related, and I just want to go home so I can read my comics and whatever else. But
Yeah.
definitely. What else do you guys offer teachers?
For teachers, yeah. So we have the curricula, obviously, and then at Denver Comic Con every year. So the next Denver Comic Con will be June 30th through July 2nd, 2017.
Okay.
The first day of Comic Con every year is what we call Educators Day. And so we offer free tickets to educators who would like to come, and all they have to do is show us some proof of working in a school or...
I had no idea.
Yeah, so it's kind of a way to come check it out. A lot of teachers feel like maybe pop culture isn't for them, or maybe it won't work in their classroom. So we kind of want to say, come see. Come see what we have to offer. We also have a professional development course through Adams State that offers about a half graduate credit that teachers can get by attending 9 panels over the course of the weekend. I should say 9 hours of panels, because they vary in length. So that's really exciting and has been a real success in the last 2 years when we've run it. And then we also offer recertification and observation hours. So if a teacher wants to come and take part in some of our education panels or events or activities, they can earn those recertification during the summer when they're kind of looking for those opportunities.
Oh. Huh. I did not know that either.
Yeah, and so, we have usually, in 2013, we had about 92 education panels. In 2014, we had 92. 2015, we had about 250. And so we're looking to increase that amount this year, too. So we think that, you come to a panel to get excited about something like Spider-Man or Marvel or Wonder Woman, but then you leave with this idea of how comics can really influence and change a student's life. Yeah.
That's really interesting.
Thanks.
I think we hit resources. How you
I'm actually
get the
curious, like, what it
resources.
would look like, as a math teacher, what kind of a lesson would look like, and with like the spinner and probability of like games and stuff. I was kind of flipping through this, and it was really cool. Like there is a serious whole progression of lessons. It's not just like, hey, why don't you just try this?
Make a game.
Yeah.
Right.
Right.
And I'm kind of just curious, like, what a lesson might look like for kind of an upper level math class. Do you have an example of that, or?
You mean from the game design perspective, or just?
Yeah, or just like from
Just in
pop
general.
culture curriculum perspective, not
Yeah.
necessarily just games.
One of the really cool things that we had, what we call the pop culture kids lab, and it's an area in Comic-Con that's focused entirely on all ages activities. So we had people like the director of The Walking Dead come and talk about how to be a director. We've had voice actors come up and talk about being a voice actor. We've had storytelling time with people like William Shatner, Alan Tudyk, so some big names kind of doing readings at our space. But last year we had, or a couple years ago I should say, we had what was called the forensics lab there. And so we had students kind of investigating a mystery and trying to solve a crime. And there was sort of a supervillain, and they had to do things like measuring footprints, looking at how different chemicals reacted because certain villains had different chemicals that were associated with them. And different, so kind of measuring those and trying to find out who was the villain that had stolen the cakes, which was our our sort of narrative for that one. So when you take those superheroes and you look at, you know, the science behind them or the math behind them, like how fast does the Flash move, and then what does that look like if they're running alongside a train, or you know, how does Superman absorb energy from the sun? Like, what is the how does that work? Like, how does that represent maybe a photosynthesis style thing?
That's interesting. I actually read it was like the physics of superheroes. It's a book, and they talk about like that they actually do try to, like, even when they wrote about Superman, they tried to make it scientifically, I mean, as much as you can with Superman, but it's kind of interesting.
Yeah, and I know that in The Flash, I know they actually brought down his speed because they figured it was mathematically impossible for him to be running as fast as he was to where he needed to go. So they actually figured out like how fast he would need to go to get from A to B or B to C. So there's some really cool opportunities, And then of course any board game that you play, especially the more complex ones, is going to have a math component, probability, statistics. So a lot of those things kind of are incorporated already into pop culture. They just aren't all the time talked about or explored.
Or even necessarily focused on.
Yeah.
Very cool. All right, well, it's time to say goodbye, but thank you so much, Adam, for joining us today and sharing everything about the Pop Culture Classroom.
Yeah, thanks for having me.
Check it out on the website if you are interested. You should definitely look into it. But thank you again. And we're going to take a little break. We'll see you in just a minute.
Hey, what are you doing? Are you just sitting there doing nothing? Check this out. Denver is growing fast. I mean like rocket to the moon fast. And one of the fastest growing sectors is construction, and they need workers, like yesterday. You know what you should try? CAD BIM. That's what I said, CAD BIM. What is CAD BIM? Computer assisted drafting, building information modeling. Only the coolest technical part of the design of buildings, roads, landscapes, you name it. Do you like computers? Do you like designing stuff? Then Emily Griffith Technical College has the right program for you. Listen to this.
This program is geared toward the student who has the energy, who has the interest in designing, design technology, learning about buildings and architecture and engineering. In this program, we have small classes, we have a small lab, we have a lot of hands-on. We have a well-rounded atmosphere with the tech and the applications behind it. So students have a well-rounded education that they receive and a lot of individual attention to help them pursue that career.
Is the industry growing? You bet it is, and Emily Griffith Technical College has got this.
In the Denver metro area, we've definitely seen an increase, probably over 10% in architecture-related jobs, and CAD specifically, I think is up about 12% in the past 4 years.
AutoCAD, Revit, SketchUp, 3D printing. Emily Griffith will get you prepared for all the latest technology.
There's actually a wide variety of jobs that students of a program like this can go into. So architecture and construction are the base, of course, but there's also engineering, interior design, construction management, civil engineering and landscape design, even transportation and manufacturing. There are lots of different avenues that this lends itself to. They'll also learn the other side, which is how buildings are put together, materials, methods, practices, and some industry practices as well.
Get up, get out, and get signed up now. The program is part-time and lasts about a year, so you can work and go to school. So the only question left is, what are you waiting for?
Hi, welcome back. Hopefully you enjoyed learning about Pop Culture Classroom. That was something I knew nothing about before.
Yeah, I never even knew that was a thing.
I didn't, but I think
really
that's
cool.
awesome. I think that's great to connect it to school. More real world things we can put in our classrooms, the better. All right, let's give you our contact information, just in case you're just joining us. You can see our phone number on the top of the screen. Get your questions called in or sent in by 5:30 today. We'll answer them as best as we can. But let's give you our contact information again. It's phone number's there. I'm not going to read that to you, but you can send your questions to us at Facebook or Twitter at EG Homework. You could text your questions in to 970-680-3771 or email us at homework@emilygriffith.edu. Those are also the way that you will contact us if you have an answer to our trivia question, which, Jordy, I think you should tell our audience one more time. What is it?
All right, today's trivia question is, what is the deepest river gorge in North America?
So we still don't have a winner for that one, so if you have a guess, guesses are welcome. Or you know the answer, give us a call by 5:30, probably a little bit before just to make sure, and you can win 2 symphony tickets to a symphony of your choice. So call us for that. Let's go back to Jordy, though, and try to get more of your questions answered since we've got the time to do it.
All right, this one has to do with radius and area. The radius of a circle is 10. It doesn't specify 10 of what, but 10. If the radius is increased by 40%, what is the area of the new circle?
Sounds like a geometry question. All right.
You can have it.
Thank you. I'm just drawing a quick circle here, and I like to, when I think about these problems, I like to kind of guess what I think is going to happen before I start them, and I think it kind of helps with like the learning process. So I would first just think like, okay, I've got a radius of a circle here. You know, the radius is 10, like Jordy mentioned, 10 what? I don't know. We'll just call it 10 units, which is what I always do when I don't know what the actual unit is. So if we're going to increase this radius by 40%, I think like, if I didn't know the answer because I do this all the time, I might think that the area of the circle will also increase by 40%. And we're going to see if that's true or not. So I'm going to have, it's definitely going to be a bigger circle. So we need to first just think about what area is and what that equation is and how do we figure that out. So the area of a circle is pi r squared. Let me write this down here so I don't forget. We're going to increase the radius, we said, by 40%. And we want to think about like what's going to happen. We know this new circle is going to be bigger, but how much bigger? And again, if I were thinking about this, I might automatically just assume that it's going to increase the rate or increase the area by 40%. We'll see if that's true or not. All right. So to find the area, all we do is plug in this unit right here. We say the radius is 10 units, so we say area equals pi times 10 squared. We're going to get area equals 100 pi, which is going to be 314.15 something units squared. And the reason why we know that is because we know pi is 3.1415 on forever. So the question is, how much are we going to increase the area by, or what would the new area be? So if we were to increase this by 40%, I might just guess that I'm going to increase it by 40%. Can I get that calculator over there? Mm-hmm. And again, I don't know if this is right or not, but I'm going to see if my guess is true. And then if it's correct or if it's not correct, we can think about like why that is the case. So if I increased it by 40%, the area it would be 439.81. Now let's see if that's actually true. Well, if we're saying that the original radius was 10 units and our new radius is 40% more, we can find that by saying let's take our old radius of 10 and multiply that by 1.4, and we're going to get 14 units now. So let's check our new area using that exact same formula and say area equals pi times 14 squared. So I'm just going to punch this in the calculator. 14 squared times pi is actually much bigger. It is 615.75 units squared. So my original guess, and again, I wasn't saying that I think this is going to be the answer, but I thought maybe, well, if we're increasing one thing by 40%, maybe we're increasing everything by 40%. But clearly that is not the case, that we're increasing the area by much more. And if you think about why, it's because we're not just increasing, we are just increasing this one radius, but one way to think about that is that radius is being increased all the way around. Everywhere is 14 units. So it does actually make sense that we're not going to increase the area by exactly 40%, that because we're expanding, and if you think about like the area of like this circle compared to the area of a much bigger circle, as we expand it, that area expands much more rapidly because we're increasing everything all the way around. And we could actually come up with a formula that, or we could actually think about how we could apply this, and maybe we could do it another time, so we're not talking about this for too long, but if we increase the radius by 40%, what percentage is the area going to increase? And that's something that we could do, I don't know, maybe another time.
I keep thinking of calculus to do this one.
And actually it's actually not really that hard. If we think about like, we could probably just do this really quick. If I said area equals pi r squared, and we want to increase it by, our radius is now going to increase by, that's really sloppy, sorry, by 40%, then we can just say that our radius is now not just r, it is 1.4 r squared. So our area is now pi times, 1.4 squared, 1.96.
So that's really what it's
Yeah,
increasing by, is it's actually increasing by 96%.
96%, which is almost double, right? So that's another way to think about that. We could kind of check that and say, well, did we increase, is 314.15, that was our original area from here. If I increase that by 96%, is it going to be this?
It should be.
Let's see. Yep, we get 700, and we actually, in my calculator, sorry, I get 615.73, and if you're like, that's pretty close, is that not exact? The reason it's not exact is because we rounded that 314.15, but that's one way to like look at, if you're going to increase the radius by some percentage, how much is the area going to increase by? And we're just really just applying our normal algebra skills to just a slightly different context in geometry.
Yeah. That's a cool question. I like that question. Okay, well, let's go back to Jordy and get some more questions answered.
All right, this one is an electricity question for Sam, and they're wondering, what's the difference between alternating current and direct current?
AC/DC.
Nice, yeah, and Jordy just told us what AC and DC stands for, which is great. So in general, when we talk about transmission of electricity, there are two general types of current: alternating current and direct current, and they're kind of exactly what they sound like. In the case of direct current, what you have is a constant stream of a certain current, a certain level of current going in one direction. An alternating current is a current that reverses direction periodically and takes the sort of, an alternating current is more like, has more of a wave form, whereas a direct current has more of just sort of a straight linear form. But they're sort of important because we use, here in the United States, we tend to use alternating current to send electricity over long distances. And this is sort of the key to why the difference between AC/DC is so important, and also highlights some interesting history around sort of the battle between AC/DC. So direct current was developed before alternating current, and at one point in the United States, it was the main way that electricity was transmitted, and it was being pushed really hard by Thomas Edison's electricity company. Shortly after DC current is starting to become widespread, This guy by the last name Westinghouse, who had his own power company, introduces alternating current. And the big difference was that if you wanted to use direct current to send voltage for over a long distance, one of the big problems that you would have is that you would lose power over those long distances. And this is true of current in general, that the longer that it travels over wires, the more power you're apt to lose. And so the problem was that as they were thinking about trying to send direct current over huge distances, they were thinking about really having to pump to get a lot of electricity flowing so that by the time it arrived at whatever location it needed to be at, it had enough power to do whatever the job was. Alternating current, because of its special form, it's fairly easy to do what's called transforming. Alternating current, you can increase or decrease the ampage or current, or the voltage or current, excuse me, of alternating current fairly easily. And so we could jump to my screen really quickly. I just have a sort of symbol diagram that shows that. So in a DC system, we have, this is just shown with ampage, but you have 100 amps traveling from a powerhouse to power lines, 100 amps traveling through the power lines, and then 100 amps going into the house. In the AC system, you have 100 amps being generated by the power plant, but then right here we have a transformer which turns it into a 10 amp signal. And then when that 10 amp signal gets back to the house, or gets to the place that it's going, it can then be increased. And so it's this ability to increase and decrease the transmission power of alternating current that makes it so useful. If you're interested in this, there's a really interesting history of sort of the battle between Edison and Westinghouse. And I'll just super briefly say that Thomas Edison, in an effort to prove that his current, direct current, was better, he had a bunch of shows where he electrocuted large animals to death. Here's an image of one of those electrocutions happening. He did it with AC current to show how dangerous AC current was. But he was really just trying to create bad publicity for AC current. It didn't work. AC current is currently the main way that we transmit energy or electricity here in the United States.
He was just killing animals.
Yeah, it's kind of an awful thing.
Not cool.
There's lots of problems with Thomas Edison, but that's one of them.
All right. Well, we need to get our answer to our trivia question. So, Jordy, read that one more time. Tell us what it was, and then what is the answer?
All right. So the trivia question was, what is the deepest river gorge in North America? And the answer to that one is going to be Hell's Canyon. It's 10 miles wide, located along the border of eastern Oregon, eastern Washington, and western Idaho. It's part of the Hell's Canyon National Recreation Area and is North America's deepest river gorge at 7,993 feet. And if you're thinking, well, what about the Grand Canyon? It's a little over 6,000 feet deep. So Hell's Canyon is actually a lot deeper than the Grand Canyon.
Have you been there, Sam?
No, I haven't actually spent much time in East. I've been to Oregon and Washington, but just in the West. I've never spent much time in the Eastern Idaho. If you want to jump to my screen just really fast, though, there's a picture of the Hell's Canyon. It's really, really beautiful.
Oh, wow.
I'm partial to the Grand, even though it's not quite as deep.
I mean, it's just so grand.
It's grand.
It's grand.
And definitely those sheer cliffs of the Grand Canyon, I think, make it
Right.
look deeper in parts, whereas the sloping cliffs of Hell's Canyon might make it look less impressive in moments, but totally beautiful.
Huh. How did it form? Does anyone know?
So in general, deep canyons form because you have an uplift of earth in some form, and the river is trying to cut towards the ocean. So if the ocean's over here way low and you've got this uplift of land, the river is going to flow over that land and try to get to the ocean, but slowly over time, it's going to cut deeper and deeper because the river would like to arrive at ocean level. And in fact, that is sort of the ultimate goal of all rivers, is to get to base level, which is to whatever they're emptying into.
Interesting.
Yeah.
Okay, well, we'll be back tomorrow. So if you didn't get your questions answered, we'll be here again from 4:30 to 5:30. Just send them in, and we'll see you again tomorrow. Thanks for joining us today.